Okay, so let's go and get our sketch back from last time. So went to File, and it was Examples, and Basics, and Blink. And here it is in here. And we will just extend this down a little bit. And so we can see it on our screen. Just for today, I'm going to delete all the top piece so we can read it all, what's going on. Okay, so this is from the tutorial Blink, so I can just get rid of that piece as well. All right, so the setup, we said pin mode, that the LED, the built-in LED was an output, and then we went into a loop, and with digital right, we turned it high, we waited for a second, with digital right, turned it low, and we waited for a second. So if I press the tick one here, it's going to compile, and it's just compiled or just compiling. I'm going to move the screen up a little bit more so you can see that. So it's done compiling, it was happy with it. So basically what that means is just checked over, and it's the program is going to download to the chip, okay? And then we've got this button here, and that's going to upload it to the chip or download it, whichever way you think you should go. And now the circuit is flashing.
Right, everybody, so this is where we got to last time. We've got the board all set up, we've got the Arduino board all set up, and we've got the LED, remember just here, flashing at a rate that we decided by changing the programming. So the next stage is, let's add some external components. Let's add an external LED and see how much control we can have over that.
Okay, I think we're going to need you to do some explaining before we get into that.
Sounds good to me, let's go. Okay, so this is what we call a schematic. This is what our circuit is going to look like, and we can draw it out. Now, across the Arduino, we're going to put 5 volts. So we know that we're going to start up here with 5 volts, okay? And the ground state, or the earth wire, is going to take it out at 0 volts. Now, we can have a look at the specs for this particular LED, and we can find them on here, okay? So we've got a lot of information on here, and some of it we're going to talk about later, but the most important pieces of information we have right now are the forward current and the forward voltage. The forward current tells us the most efficient current to be flowing through the LED to get it to work. The forward voltage tells us the potential difference, or the voltage that we need across the LED to make it work. So we've got 30 milliamp forward current, and we've got a forward voltage of 2 volts. So if we go back to our schematic, we can add that information in. So as we said, we've got 2 volts across the LED, and this is the symbol for an LED, and we'll talk about why it's this symbol in a moment. But the key thing is it's a light emitting diode, and that's why we have the arrows moving out. And we also know that we've got 30 milliamps going through the LED. Now 30 milliamps sounds like a weird kind of number. Maybe we've heard of amps. But think about meters. We have millimeters, and milliamps is exactly the same thing. We have to divide that by 1,000 to get it into amps. So in this case, we're going to have 0.03 amps through our LED. Now, the last thing we can put across here is to say, right, if this is a 5-volt circuit and it's series, one after the other, we need to have 5 and we need to get to 0. So if there's going to be 2 volts across the LED, to get rid of the remaining 3 volts, we have to have 3 volts across our resistor. Now, this gives us a lot of information, but the key thing we need to put in here is a resistor. Now, a resistor is designed to protect the circuit. It's going to slow the current down and protect the LED. So we need to make sure it's the right resistor. Now, we've got a very powerful equation we can use, which is, in summary, V equals I times R. Now we can add some letters to that, or add some words, sorry. It's the voltage, or the potential difference, is the same thing, and equals the current multiplied by the resistance. Now, you can see the letters linked back. V for voltage, R for resistance. Current's a weird one. It comes because the French did a lot of initial work on electricity, and they named it for intensité des électrons, which is why it's an I. Now, quick rearrangement, don't worry too much about the maths, but you can work out that R equals V divided by I. Now for our resistor, that means that we've got 3 volts passing through the circuit, and we've got 0.3 amps along this whole wire here. So we've got 0.03, which is going to give us 100 ohms. Now that's the unit for resistance, ohms. It's got a little symbol here with the horseshoe, and it's named after Georg Ohm, a German physicist. So we need a resistor of 100 ohms.
Except that we're not going to use 100 ohms.
Why not? The math says 100 ohms, and that's what I love.
I know, and I tend to agree with you on that. However, if all of the pins from the chip were given out 30 milliamps, the chip will heat up too quickly. We could put that down significantly, the amount of current, and still see the light. It will be much better off for you.
Okay, so if we use a high resistor, we're going to protect the chip.
Yes.
So my question to you is, how do I take all this theory and actually put it into a chip?
We're going to use a breadboard. Okay, so this is what we call a breadboard, and it's a way to connect components together. Along here, we've got a very long line, and all of those holes are connected together. Every single one of them. And we use the outside one, we use that top one there, mainly for positive volts, the plus volts. We use the one next to it, they're all connected together for 0 volts. And then along here, these 5 here are connected together, but they're not connected to the ones next to them, and they're not connected to the ones opposite. So when we're going to put our LED in, we are going to put one leg in here and one leg in here, and we're going to connect our LED up in here. And then we're going to bring a leg out here, we're going to put our resistor in, and we're going to put another leg back into here. And then we take a wire out, and that's going to go back to our pin 13. And this, we're going to put a wire in here, and that's going to go to 0 volts, and that's pin 13. Okay with that?
Okay, so let's start building. So the first thing I do is get hold of my LED. Now I hold the LED up to the light, and we'll talk about this in a little while. We'll go into a bit more detail on it. But if you hold an LED to the light, you'll see that there's a big flag and a little flag. Now the big flag tells me that that is the negative end. So if I hold mine to the light, I can see that this side of the LED is negative. So I'm going to place that in my breadboard with the negative onto the hole next to this blue line. Okay, so I'm going to push that in there. Now I need to add in my resistor. Okay, so if we remember, I can connect one side of the resistor into this section here, so it's in the same row as my LED, and then the second side will be connected on the other side, on the other sets, and I just need to push that in there, push that in there. Sometimes you need to push a little bit harder. Then I'm going to take my black lead, okay, and that black lead is going to be connected up here into the same as the same whole group as the LED. Okay. Oh, sorry. No, say that back. Sorry.
So you're just putting it into where the positive goes. It needs to be on the same one and the blue one as the LED.
Yeah. So put that in the negative side. Make sure it's on the blue side there. And I'm going to connect that into the ground. Now, if you look very carefully on your Arduino board, you'll see that ground is one of these two here, G and D. So we're going to slip that one into the G and D. And then this side is going to go, and we're now going to have to complete the circuit, because remember, we need a complete circuit. So I go into one of the same row as my LED. Okay, so I'm going to push that in there again, a little bit stiff at times, and then I'm going to go and find pin 13. If you remember, pin 13 is the one that we are programming at the moment. So if I just put that into pin 13, et voila. I've now got a flashing blue LED. So I've got a complete circuit, and the LED is obeying the programming that we put in last session.
That's cool. Happy with that. Do you think now, because you've had to go with the circuits, but that's a little bit of your expertise. You haven't really had much expertise on the programming side. Do you reckon that you can get the programming another LED?
Oh, with your help, let's give it a shot.
Okay, so go and put these two LEDs in and put them in parallel with there, and I'll get you a new wire to put into pin number 12.
So I'm going to put in another in the LED. So again, I'm going to hold it up to the light, find the big flag, which is negative. I'm going to go into the negative here. Okay, so I'm going to go in here, in there. Okay, same again. I'm going to put another resistor in. Okay, so again, I'm using the same row. Okay, if you remember, it's got to be in the same row because they're connected. And then by having two ends of the resistor in each side, I'm connecting those up. Okay, so I'm just going to have to push this one in a little bit harder to make sure it's connected. There we go. Okay, so now I'm going to have to think, how am I going to connect this up to my pin? Okay.
So put the one back in from pin 13 to the end of that resistor.
So
let's get that one flashing again.
This resistor goes into pin 13. Okay, so there's pin 13.
All right.
Yeah.
And then put that one in for the other end of this resistor just here.
Okay.
And you can pick basically your whichever number you want, but you might as well go with pin number 12, which is right next to it.
Okay. Oh, sorry, it's a bit difficult to get that one.
It is always a bit fiddly when you're first going with it.
Okay, and we're going to go into pin number 12 here.
Yeah.
Okay.
Okay.
Now, do I need to ground another wire? Do I need another wire to complete this?
No, because what's happening on here is that it's all connected to the same ground on there.
Okay.
So it's using the same one. But interestingly, this one's not working anymore because I think your resistor's just come out.
There we go.
Okay, so we can put it in, it's working. But why is the other one not working? Just push it down, just hold it down with your finger for a minute. We can sort it out in a second when we finish talking.
There we go.
Okay, so why is the white one not working?
Is it because we've not told the circuit to do anything with it? We haven't told pin 12 to do anything.
Exactly, so that's what we're going to do now.
Okay, so now we're getting onto the programming side. I'm going to need a little bit of help. We're getting out of my comfort zone here.
That's all right.
How am I going to tell the Arduino, how am I going to tell the board that I need it to go looking for another pin?
Okay, so read what we've got there. We've got some comments on the screen, okay, they've got the // but we can ignore those. The first real instruction on there says void setup. And what that means is that's the piece of code that's going to happen once at the very start, and then we forget about it again. So that's where we're going to tell it the things that we need to tell it at the start, so it knows what's going on. So have a look underneath there, and what can you see underneath there?
So it looks like we're telling the board to initialize digital pin, LED built in as an output, and then it gives us some gobbledygook.
So it says on there pin mode, LED built in output. Okay, so that tells it that pin LED, so the pin built in is pin 13, so it knows that already. Okay, and it says it's going to be an output. So what do you think we need to do?
So we need to tell it that 12 is now an output as well.
Yes, so just copy the line.
Okay, so if I go into here, click return, and I should be going pin mode, open brackets. Now, do I need to call it anything, or
no, just call it 12.
Just call it 12.
Yeah.
Okay.
Later on, I'll show you how to do that a little bit better, but that's not a worry right now.
I don't understand your computer. That's why.
There's the brackets.
There we go. Okay. So we're going to call it 12.
Yeah.
And then I need a comma by the looks of it.
Yeah.
And then just output.
Yeah. In capitals.
In capitals.
Yeah.
Yeah. And then looks like I close the brackets. And is that semicolon? Let's put the semicolon in there. Okay.
Okay.
So I've told it that I now want pin 12 to be an output. Great.
Okay.
Next, what's next? So
So we don't need anything else on the setup. The chip now knows pin 12 is an output. It's not expecting to receive a signal via a switch or anything like that. It knows that it's sending the signal out.
Yeah.
Okay. So let's go down. The next piece of code is the loop. Okay. So this is what happens again and again and again. The setup has happened. All right. And it's now going to go around again and again. So what happens on the first line of the loop?
Okay. So we've got digital write, LED built in goes to high. And that, by the looks of it, of the explanation, is turn on the LED on a high setting. So the voltage level is high. So we're up at the 5 volts there from our earlier discussion. Yeah.
So what we want one LED on at a time. So we want the other LED on now. So the other LED off now.
Okay.
So when the blue one's high, we want the white one low.
Okay. So in theory, I should be able to then go. So I just use digital. If I could spell digital, that would help, wouldn't it? Digital, and I guess there's a capital in there, digital write, and then this time I'm going to be pin 12, comma, oops, and then is that, I want low, is that?
That's right.
Okay, and it looks like we've got another semicolon at the end.
Yeah,
okay.
All of the lines have a semicolon at the end.
Okay, so, and then I can move on from that one, I assume.
Yeah.
Okay.
So what's happening after that? You turn the blue LED on, the white LED off. What's happening next?
Then we've got a delay of, now that was in milliseconds, wasn't it? So
yep.
1,000 milliseconds was a second. Yep, wait for a second on the screen there.
Cool. So,
and then the built-in LED goes low.
Yeah. So if the built-in LED goes low, what do we want our other LED to do? Okay, what do we want our other LED to do?
We'll want our other LED to go high, I suppose, if we want to turn it on.
Go on then.
Okay, so we'll hit that, and then we go digital right, wasn't it?
Yeah.
Right, pin 12, low, oops, no, I didn't put a comma in there, did I? Low, close the brackets, semicolon, yeah, I think.
Okay, what's happening after that?
Then it's going to go, in this case, the white LED is going to go off for 1,000 milliseconds or a second.
Okay, all right. So what we've done here, if you've turned the blue one off, but you've also turned the white one back off again. The white one doesn't want to go low. It's already been low.
Of course,
yeah.
It wants to go high.
Yeah.
So I need to put, well, let's not spell it like that. Let's put high in there. Okay, got it.
All right, so we're going to check the program by pressing the tick at the top of the screen, and it's going to run through and it's going to compile it, and it's going to say whether there's any errors. Oh, we've got an error. What have we got missing down here? What's it telling us?
It's telling us that I can't spell digital, is what it's telling us there.
Go for that,
so I will correct that. Oh, right, that's just an appalling spelling. I don't know how that's happened.
You wait until you get to do the analog stuff.
Digital,
that's
okay.
Very American.
So that, oh, I've still got an O in there. This is digital, right, okay. So tick it again.
Go for the tick.
Compiling sketch. That's much better.
Excellent. So now do the one next to it to download to the chip. And what's happening on the board?
Yeah, it's flashing.
Cool. All right.
Okay, so I am loving this. On and off, so far so good. Now, I'm going to get a bit pedantic. Now I would like to change the brightness, please.
Okay, so there's two ways of doing it. There's the good way and there's the bad way. All right? The good way is quite technical, but we can do it. The bad way will be reducing or changing the resistance. So if we increase the resistor value, then that will limit the amount of current flow and it will make it dimmer. Make sense?
Yep, absolutely. So we change these two components for a much higher ohm resistor. So currently, these are what, 200?
Yep, 220.
It's 220. So if we increased it to, say, 400, we can make both LEDs dimmer because we'd be slowing the current down with an increased resistance.
Well, what we could do is replace it with a variable resistor, which is the one with a dial on, like we change the volume and things like that, or a dimmer like we'd have on a switch at home, and that would change that we could vary the amount of resistance. Now, the problem with that is you would have, in fact, let's draw a graph.
Sounds good. Let's have a look. I do like a graph. So my understanding of LEDs basically gives us a graph that looks like this. So I start changing my variable resistor. As I decrease the resistance, I'm going to increase the potential difference and increase the current. So my initial little turn is going to go, well, nothing. Keep turning, keep turning, keep turning until I reach just before 2 volts, which is the threshold voltage. And then I turn it a little bit, but I get a huge increase in brightness. Now, in my mind, that seems incredibly fiddly because it's only really the last fraction of a turn that's going to give me the increase. Is there a better way to get this graph a bit smoother?
Yes. Okay, so what we're going to do now, instead of varying the voltage, we're going to keep the voltage exactly the same, but we're going to limit the amount of time that the output pin is on. And what that's going to do here, so we look at this, and this is really short periods of time. This is maybe 1 millisecond, the whole length of that time. And we turn it on for half a millisecond, and we turn it off for half a millisecond. And that's going to give us a really close approximation to 50% dimming. And then by changing the amount that this is turned on and off, we can change and turn it to maybe 75%. There we go. So this is now 75% duty cycle, 75% on, 25% off, and that's going to give us a 3/4 dim. Now that sounds incredibly difficult to program, but the beauty of the Arduino is somebody's done the difficult bit for us. Okay, so you want it dimmed? Let's do some pulse width modulation. And so what I'm going to do here is I'm going to set you now, and I'm going to get rid of all your lovely code.
I spent literally minutes on that. It's outrageous.
We're going to save it. That's okay. I'll be fine. All right. So we're going to start the loop again here. And what we're going to do is we're going to create a loop. And our looping is really big and important in coding. And 4 tells it we're going to do a loop. All right. For an integer, that's what int is. And we're going to call it x because algebra, obviously. For int is x on there, we're going to put a semicolon. And then we're going to say we want it to do, well, x is less than 256. So 256 is a very important number in programming, but we haven't got to worry about that today. All right, every time it goes around the loop, all right, so it's going to start with x is 0, and then it's going to keep going all the way up until x is less than 256. So the last body it will be on will be 255.
Yes.
Makes sense?
Makes sense.
And then what's going to happen is every time it goes around the loop, we want x to increase by 1. That's what that's doing. Makes sense to you so far?
Yes, I think so.
All right, and so everything we want it to do in there has got to go inside a set of curly brackets. So the end brackets have just been put in for us, which is cool. All right, so what do we want to do? We're going to use an analog write. So this is very American spelling, all right? Analog write. So which pin? I want pin 13. Come on.
Yes.
How bright do I want it to be? I want it to be X brightness. So the first time round, that's going to be 0. That makes sense?
Yep.
The next time round, it's going to be 1. And the time after that, it's going to be 2.
Up to 255.
Up to 255.
Okay.
So it's gradually going to get brighter.
Yes.
Make sense?
Okay, yeah, perfect sense. So.
Okay. So we're going to close that analog write off, and then we're going to come in here. And we're also going to do another analog write. And this is going to go backwards. So this is pin 12.
Yeah.
Okay. And what we're going to do here, we're going to 255 take away x. So this is going to start up when x is 0. 255 take away 0 is 255.
Yeah.
So this is maximum brightness. And every time it goes around the loop, it's going to get 1 dimmer.
So it's going to be the exact opposite of the blue light, which is from pin 13.
Blue light should be coming on, white light should be going off. Does that make sense to you?
Yep.
Okay, so what we're going to do now is we're going to put a small delay into it. Let's do 100 milliseconds for now, and we can see what is happening there. And I'm going to put my colon in there, and that's it. Should we go and have a look?
Yep, let's run it through and see what happens.
Let's compile it.
Success first time, eh?
Oh, yeah, doesn't mean the program won't. The computer may not understand it perfectly, but it might not be what I want it to do. Okay. Okay, so we got a little bit of a confession to make. It didn't work first time. It's like, whoa, what was going on? Because I was pretty sure my code was good. And what it turned out to be is that pins 12 and pin 13 aren't set up for pulse width modulation. If you look at your board, number 3, number 5, number 6, number 9, 10 and 11 have all got a little squiggle in front of them, and that means that they can do pulse width modulation. And like a twonk, I completely forgot about that, but there we go. But it happens sometimes. But you can see it's working now, that the white one is getting, the dimming is changing, the blue one is going down, and the white one is going up. Okay, in brightness. Okay, happy with that?
Very happy, yeah. We've come a long way today. Well, for me anyway.
All right. Okay, so next week, what do you fancy doing?
What I'd quite like to get my head around is how external inputs can affect the Arduino board. So why don't we look at something like the ultrasound distance finder, range finder, so that we can talk about how we can change inputs.
Okay, what we'll do first then, we'll have a little look at a light sensor and maybe a heat sensor, because they're nice and quick and easy to do. and then the natural progression onto that will be the ultrasonic rangefinder. How does that sound?
Sounds good to me. So a light-dependent resistor
Yeah.
and a thermistor.
Yeah.
Now we're in my neck of the woods.
Excellent.